This is the OCR GCSE 9-1 Maths Paper 2 from the June 2019 series, and it's the non-calculator paper from the foundation tier. Question number 1 for part A. For the first part, we have to work out £4.25 plus £5.18. Well, what we are doing here is adding two numbers together, and if we align the digits and add vertically, we have 4.25 and 5.18, and what we are doing is adding these together. 5 plus 8, that's 13, so we've got the 3 here, and then we carry the 1, so we've got 1 plus 2 plus 1, that's 4. Then we've got the decimal point, and 4 plus 5, that's 9, and therefore we have £9.43. We've got £9.43. For the next part, we've got minus 8 plus 11. Well, we're at minus 8 on a number line, and if we add 11, it turns out we get 3. Another way of thinking about this is 11 take away 8, which is of course 3. And for the third part, we've got minus 6 times minus 9. Well, the minus and the minus will give us a plus. We are multiplying, so we've got positive 6 times by 9, which is positive 54. Next, for part B, we have to use one of these symbols. We've got these strong inequality symbols, and we've got an equal symbol to make each statement true. Well, we've got 4.5 and 4.34. You can see 4.5 is greater than 4.34. And then we've got 3/4 and 0.8. Well, 3/4, this is the same as 0.75. So we are comparing 0.75 with 0.8. You can see 0.8 is greater than 3/4. So we've got 3/4 is less than 0.8. And then we've got 3/5 and 0.6. Well, 3/5, that's the same as 0.6. So indeed, 3/5 is equal to 0.6. Question number 2. By rounding each value to one significant figure, we have to estimate the cost of 3.9 kilograms of apples at 87p per kilogram. Well, if we round the 3.9 kilograms to one significant figure, we have here 4 kilograms. And if we round the 87p per kilogram to one significant figure, we would have 90p. And so therefore, we have to estimate the cost of 3.9 kilograms of apples at 87p per kilogram. Using our rounded values, we have to estimate we have to use the 4 kilograms and the 90p. So therefore, if we have 90p per kilogram and we've got 4 kilograms, then of course the cost would be 90p multiplied by 4, which is 360p. And if we divide this value by 100, we can see that 360p is the same as £3.60. So we've got £3.60 as our answer. Question number 3. We have to complete each statement. For the first part, we've got 3/7 equals something over 28. Well, you can see to go from the 7 to the 28, we multiply by 4, and therefore 3 times by 4 is 12. So 3/7 is the same as 12 over 28. Next, we have 4.5 being something equal to something over 2. Well, what we need to do here is convert the 4.5 into a top-heavy fraction. And to do this, we've got the 4 times by the 2 plus this 1, and then we divide by 2. So here is what the 4.5 is. And therefore, we've got 8 plus 1, which is 9 on the top. On the bottom, we've got 2. 4.5 is the same as 9 over 2. For part B, we have to work out 2/3 minus 1/5. Well, what we can do here is combine these fractions. We would have here 2 times by 5 minus 1 times by 3 over 3 times by 5. So if we work this out, what we have is 10 minus 3 over 15, which you can see is equal to 7 over 15. So we have 7 over 15. Question number 4. For part A, we have to work out 0.7 times 0.3. Well, here we would expect to have 2 decimal places. If we had 7 times by 3, that would be 21, and therefore 0.7 times 0.3, that will be 0.21. Another way of thinking about this is if I multiply this by 10, we would have 7, and if I multiply this by 10, we would have 3. So 7 times by 3 is 21, and because I times this by 10 and this by 10, I'd have to divide this by 10 by 10. In other words, I have to divide 21 by 100 to get 0.21. And now for part B, we have to work out 0.48 divided by 6. Well, if we had 48 divided by 6, this will equal 8. But you can see, comparing the 0.48 with the 48, 0.48 is 100 times smaller than the 48, and so therefore dividing the 8 by 100, we end up with 0.08. Question number 5. For part A, we have to complete the following. For the first part, we've got 5 squared. 5 squared is the same as 5 times by 5, which is 25. And for the next part, we have to work out the cube root of 64. Well, we need to think to ourselves, what number do we have when we multiply it by itself 3 times, we get 64. Of course, cube root of 64 is just 4. And now, for part B, we have to work out 2 cubed times 49. Well, here, 2 cubed, that's equal to 8. Square root of 49, that's 7. 8 times by 7 is 56. So we have 56 as the result of this calculation. Question number 6. Here is a function machine. We've got an input, we times by 5, we subtract 3, we get an output. We have to find the output when the input is 7. Well, if we input 7, then we've got 7 times by 5, and then we subtract 3, and from here we get an output. So the output is equal to 7 times by 5, take away 3. 7 times by 5, you'd find that to equal 35. So we've got 35 take away 3, which is 32. So we've got 32. And for the next part, we have to work out the input when the output is 42. Well, if the output is 42, and let's suppose our input is I, then we have input times by 5, so we've got 5i, take away 3, this is equal to 42. Now let's solve this equation. If we add 3 to both sides, you'd find 5i to equal 45, and if we divide both sides by 5, what you will find is I is equal to 45 divided by 5, which is 9. So the input here is 9. For the next part, the input is x and the output is y. We have to write an equation for y in terms of x. Well, if we input x and we multiply that input by 5, we would have 5x. And then we subtract 3 and we get an output of y. So therefore we have y equals 5x minus 3. Question number 7. AB and CD are parallel lines. That's what we see here. We've got a parallel line pair here and here. And EF and FB are straight lines. We have to complete the following statements. Well, we see that x is equal to 55. That's because, well, this angle here is equal to this angle here. So x is equal to 55, and the reason for this, we have alternate angles. And then we see that y is equal to 70. Well, this angle here is equal to this angle here. So the reason y is equal to 70 is we have corresponding angles. Question number 8. Darren has these 20 crayons in a box. He has 8 blue, 4 red, 5 black and 3 green. He chooses a crayon at random from the box, and we have to find out which arrow shows the probability that the crayon is blue, yellow and not black. Well, if we find out the probability that we have a blue, well, there's 20 counters in total, and of those which are blue, we've got 8. And this simplifies to 2/5. 2/5 is the same as 0.4. So the arrow which shows 0.4, well, here we've got 0.5, here we've got 0, here between 0 and 0.5 we've got 0.25, so therefore here would have 0.4. So therefore we have arrow C. And now to find out the probability that we have a yellow, well, there's 0 yellow crayons here, so that is impossible. We have a probability of 0, and that would correspond to arrow A. And then looking at the probability that we don't have a black, well, there's 20 counters in total, and of those which are not black, we have 8 plus 4 plus 3. So we have 8 plus 4 plus 3, which are not black, and therefore this will simplify to 15 over 20, which is the same as 3/4, of course, equivalent to 0.75, which corresponds to arrow A. And now for part B, Darren buys 16 more crayons that are either blue or red. He puts these in a box with the 20 crayons he already has. He now picks a crayon at random from the box. The probability that he picks a blue crayon is evens. How many red crayons did he? Now, what's happening here is we've got 20 crayons already, and we're adding on 16 which are either blue or red. So it turns out here that we get 20 plus 16, which is 36. Now, this tells us we've got 36 in total now. And the probability that we get blue is evens, so therefore the probability of getting a blue will be evens. So out of 36, how many of those will be blue is what the question is. Well, if the probability is evens, then that tells us we have 18 which are blue. Okay, let's just clarify this. We have the probability of blue equaling 18 over 36. So that tells us that we've got 18 blue. In total now. And if we look at what we had before, we had 8 before. So we had 8 before, and we're going to 18. So that tells us that we've added 10 more blue. And if we add 16 new counters in total, that means that we have 16 take away 10, which is 6. So we added 6 more red. So therefore he got 6 red counters, crayons. Question number 9. The graph shows Sarah's journey from her house to a shopping centre, so that's what we see here. And for part A, we have to state an assumption that has been made when the graph was drawn. Well, you can see here we have straight lines, and therefore our assumption is she travels at constant speeds. And for part B, what is the distance from Sarah's home to the shopping centre? Well, you can see the shopping centre is over here. We've got a distance of 36 kilometers. And now for part C, between which 2 times did Sarah stop? Explain how the graph shows this. Well, we stop over here when the gradient here is 0. This implies we've got no speed. So it's in between this time and this time, from 10:30 to 11 AM. So we have from 10:30 AM to 11 AM, and the reason for this is we have 0 gradient between these times. We have a horizontal line. And now for the first part of part D, Sarah stays at the shopping centre until 1300 hours, in other words 1 o'clock. She then travels home without stopping. Her journey home takes 40 minutes. We have to complete the graph to show this information. Well, what we have is her taking 40 minutes to get home, and she stays at the shopping centre until 1 o'clock. So here, if she stays at the shopping centre till 1 o'clock, that means she's not moving anywhere. So from here to here, we'll draw this on. We have her staying at the shopping centre till 1 o'clock, and then she takes 40 minutes to get home. Okay, so we have her journey home taking 40 minutes. So from 1 o'clock adding on 40 minutes, well here you can see we've got 1 hour 30 minutes. So 40 minutes takes us up to here. So now if we join this up with a straight line, as we see here, this is her journey home. And then for the next part of part D, we have to work out Sarah's average speed for her journey home. Give your answer in kilometers per hour. Well, what you can see here is for her journey home, we have a distance of 36 meters from the shopping center to home, and the time is 40 minutes. So, first of all, we know speed is equal to distance over time. Now, we have to give our answer in kilometers per hour. So what we'd have to do as well is convert the 40 minutes into hours. To go from, we'll write it down here, to go from minutes to hours, we would have to divide by 60, and hours to minutes we would have to times by 60. So therefore, 40 minutes, that's equal to 40 divided by 60, which is 2/3 of an hour. So 40 minutes is 2/3 of an hour. So we've got the distance, we've got the time, we can therefore work out the average speed. For the average speed, we have the distance 36 divided by 2/3. And of course here we've got kilometers per hour. And now we need to work out 36 divided by 2/3. Well, this is the same as 36 kilometers times by 3/2. And then obviously we've got 1/hour. So 36 divided by 2, that's 18. Timesing that by 3, we get 54. So we've got 54 kilometers per hour. So we've got 54 kilometers per hour. Question number 10. For part A, we have to simplify fully for the first part. 3t plus 5u minus 2t plus 3u. Well, what you can see here is 3t minus 2t, that's just 1t. And 5u plus 3u, that gives us 8u. So we have t plus 8u as our simplified expression. And then for the next part, we have 6a times by 2a squared. Well, we can rewrite this as 6 times a, so that's 6a, times 2 times a times a. 6 times 2, that's 12. A times a times a, that's a cubed. So we've got 12a cubed. And now for part B, we have to make x the subject of the formula y equals x squared minus 1. Well, over here, if we add 1 to both sides, you will find x squared to equal y plus 1, and if we square root, x is equal to y plus 1 square rooted. So we have x equals y plus 1 square rooted, as we see here. Question number 11. A doctor records the ages in years and the heights in centimeters of 10 girls, that's what we see here, and the points for the first 6 girls are plotted on the scatter diagram. For part A, we have to plot the points for the remaining 4 girls. So we've got 390, so 3 across 90 up, that goes here. Then we have 6 and then 117, so we've got 6 over here, and then 117, well here we've got 110, and then we've got 115, 16, 17, that goes here. And then we've got 9, 127, so 9 goes here, and then 127, that goes here, and then 4 and 103, so 4's over here, 103 is over here. So here are the other points plotted, and then we have to describe the type of correlation shown in the scatter diagram. Well, you can see as one quantity increases, the other also increases, and therefore we would have a positive correlation. Now for part C, the doctor says that by using a line of best fit on the scatter diagram, the height of a 6-year-old girl is around 95 centimeters. Does the scatter diagram support the doctor's statement? Explain your reasoning. Well, what we'll do to begin with is we'll actually draw on a line of best fit. A line of best fit goes through as many points as possible. We want roughly the same amount of points above the line as we have below the line. Now, we have here the height of the girl being 95 centimeters of a 6-year-old girl. So with a 6-year-old girl, if we draw a line up, as we see here, so let's just do this in pen. And then if we draw a line across from this point, what you'd find is we have a height of 114. So here what you can see is the height is approximately 114 centimeters, and therefore you can see that the scatter diagram does not support the doctor's statement. It is too low. And then for part D, we have to explain why the scatter diagram and the line of best fit should not be used to estimate the height of a 12-year-old girl. Well, if we take a look at a 12-year-old girl, you can see from the information given, we've only been given information for up to 9 years old. So therefore, 12 years old is outside the dataset. Let's just write that down. You can see we only have heights for age up to 9 years old, and age 12 is outside the dataset. Question number 12. Kate is 5 feet 2 inches tall. Alice is 1.57 meters tall. Alice says that she is taller than Kate. Use the conversions below to decide if Alice is correct. So we've got 12 inches is 1 foot, and 1 inch is 2.5 centimeters. Well, what we can do here is convert everything into meters. So if we consider Kate is 5 foot 2 inches. So 5 foot, well, we know that 1 foot is the same as 12 inches, so therefore 5 foot will be equal to 12 times by 5, which is 60 inches. So we've got 60 inches plus 2 inches. So this is equal to 62 inches. And if we convert the 62 inches to centimeters, well, we'd have 62 times by 2.5 centimeters. So here, 62 times by 2, that is 1, well, we'll work this out on the side actually. We have 62 multiplied by 2.5, which we can split up as 2 and 0.5. So here we have 124, 31. So adding these together, 120 plus 30, that's 150, plus another 4, that's 154, plus another 1, that's 155. So here we get 155 centimeters. And then to go from centimeters to meters, we would have to divide by 100. Meters to centimeters, we have to times by 100. So if I divide 155 by 100 to convert this into meters, we've got here 1.55 meters. And this is greater than the 1.57, which would correspond to Alice's height. And therefore, what you can see here is, in conclusion, Alice is correct. Question number 13. Rashid is making cupcakes using these ingredients. That's what we see here. We've got 120 grams of flour, 140 grams of butter, 4 eggs, 60 grams of cocoa powder, and 50 milliliters of water. And for part A, how many eggs does he need to make 60 cupcakes? Well, to make 20 cupcakes, what you can see is we need 4 eggs. And therefore, for 60 cupcakes, of course 20 to 60, that's 3 times. So we need to do 4 times by 12, rather 4 times by 3, which is 12. So therefore he would need 12 eggs. And now for part B, how much butter is needed to make 5 cupcakes? Well, you can see for 5 cupcakes, that's 4 times smaller than 20. So therefore we need to do 140 divided by 4. So 140 divided by 4, you'd find this to equal 35. So we need 35 grams of butter. And then for part C, Rashid has 210 grams of cocoa powder and plenty of the other ingredients. He says that he can make at least 75 cupcakes. Is he correct? Explain your reasoning. Well, he has 210 grams of cocoa powder. So for 20 cupcakes, you can see we need 60 grams of cocoa powder. So for 20 cupcakes, we need 60 grams of cocoa powder. Now he has 210. So what we can do here is find out how much 30 grams will get us. And you can see here we had to divide by 2. So here dividing by 2, we have 30 grams of cocoa can make 10 cupcakes. And he has 210 grams of cocoa powder. So if we times this by 7 and timesing this by 7, you can see that he can only make 70 cupcakes. He's saying he can make at least 75 cupcakes, and therefore you can conclude he's wrong because he can only make 70 cupcakes, as we found here. Question number 14. You can see triangle A is drawn on this grid over here, and we've got this point P, and we have to enlarge triangle A with scale factor 3 from the center of enlargement P, label the triangle B. Well, if we grab different colours, well, you can see from P to this point, that's 2 across and 1 up. So if we enlarge by scale factor 3, we'd have to go 6 across and 3 up. So the corresponding point would be for this point over here. And then for this point, we have 3 across, 1 up. So therefore, if we enlarge that by scale factor 3, we've got 9 across and 3 up, like we see over here. And then you can see for this point, well, we've got 3 across and 3 up, so therefore we'd have to go 9 across and then 9 up. That takes us up to here. Okay, so if we draw on our shape, here is our new shape, and what we were told to do is label this B. And then we have to describe fully the single transformation that maps triangle B onto triangle A. Well, what we have over here is to go from A to B, we had a stretch scale factor by 3. And because we're going from B to A, you can see we're going 3 times smaller. So therefore, we'd have a stretch with scale factor 1/3 this time, because we're going from B to A, we're getting 3 times smaller. And then our center will still be this point P, which has coordinates -4, -4. Question number 15. Ed has a card shop. He buys a particular card for £1.20 and sells it for £1.68. We have to calculate his percentage profit on the card. Well, for the percentage profit, this is equal to the change over the original multiplied by 100. So we've got the change over here being £1.68, take 120, and then our original is 120, and then we times all this by 100. So if we work this out, 168 take away 120, you'd find that to equal 0.48. So here we've got 0.48 over 120 times by 100. And if it makes life a bit easier for you, then what you can do is multiply everything here by 100. So we have 48 over 120 times by 100. Now 48 over 120, if we divide the top and bottom by 24, then what we'd have over here is 2/5. So we've got 2/5 times by 100. So what we did over here was we divided the top and bottom by 24 to get this amount over here. So 2/5 times by 100, well, that will just be 40%. So we've got here 40%. And now for part B, Ed's profit on good luck cards in 2018 was £360. This was a decrease of 20% on his profit in 2017, and we have to work out Ed's profit on good luck cards in 2017. Well, over here, if we decrease by 20%, that means we've got 80% left over. And this 80% would correspond to the £360. And we have to find out essentially 100% the original amount in 2017. Well, what we can do first of all is find out what 10% is, and then find out what 100% is. So, to go from 80 to 10%, we have to divide by 8. So we also have to do the same thing on this side. We have to divide by 8. So 360 divided by 8, you'd find this to be 40. Rather, here we've got 45. And then for 100%, we'd have to times by 10 on both sides. And if we times by 10, of course, here we've got 450. So we've got £450, which was the profit in 2017. For question number 16, a sunflower grows at a rate of 4 centimeters each day. How many days does it take to grow from a height of 80 centimeters to more than 106 meters? Well, what we can do first of all here is convert the meters to centimeters. To go from meters to centimeters, we times by 100, centimeters to meters, we divide by 100. And therefore, what you can see here is 1.06 times by 100, that's 106. So we have 106 centimeters. And the reason I wanted to convert it to centimeters, the growth rate is in centimeters, and the original height is also in centimeters. It makes sense for us to make the units consistent. So then we've got our original height, which is 80, so this is the original. And if we're growing at 4 centimeters per day, well, After the first day we've got 84, after the second we've got 88, after the third we've got 102, after the fourth we've got here 92, after the third, after the fourth we've got 96, then we've got 100, then 104, then 108, and we could continue, but we're looking for how long it would take to reach a height more than 106 centimeters. Well, it will take here 1, 2, 3, 4, 5, 6, 7. So of course it'll take 7 days. And then for part B, if the slum flower grows at a faster rate, how would this affect the answer to part A? Well, of course it will take fewer days. Question number 17. A bag contains 4 red counters and 3 blue counters only. Jack picks a counter at random and then replaces it. Jack then picks a second counter at random. Part A, we have to complete the tree diagram. Well, you can see that if he replaces it, the probabilities will remain the same between the first pick and the second pick. So the probability of picking a red will remain as 4/7. And therefore, to find out the probability of blue, that will be 1 take away 4/7, which is 3/7. So the probability of picking blue is equal to 3/7. And then for part B, we have to work out the probability that Jack picks 2 red counters. So for part B, we've got the probability of picking 2 red. Well, probability of picking a red from the first pick, that'll be 4/7. And then for the second pick, again, that'll be 4/7. Here we've got 16 over 49. So therefore the probability is equal to 16 over 49. Question number 18. Adam buys some theatre tickets in a sale. The normal prices are £80 for each adult ticket, £40 for each child ticket. In the sale, the prices are reduced by 15%. Adam buys 2 adult tickets and 1 child ticket at the sale price. A 2% booking fee is then added to the total cost of the tickets. We have to calculate the total amount that Adam must pay. Well, over here, he's buying 2 adult tickets and 1 child ticket. And what's happening is the sale price is reduced by 15%. So for the normal prices, the total would normally be 80 plus 80, and that's because we have 2 adults, plus 40, and the reason we add 140 is because we have 1 child. So it turns out here we get 160 plus 40, which is 200. So the normal price is £200 for the 2 adults and 1 child. And with the reduction, what we need to do is take 15% off the 200. Well, first of all, 10%, you'd find that to equal 20. 5%, you'd find that to equal 10. And therefore, 15% is equal to 20 plus 10, which is 30. So therefore, with the reduction, the cost is equal to 200 take away 30, which is 170. So it costs £170. And then a 2% booking fee is then added to the total cost of the tickets. So with the booking fee, we need to add on 2% onto this amount here. So first of all, if we work out what 10% is, 10% is equal to 17, and therefore 1% is equal to 1.7, and therefore 2% is equal to 2 times by 1.7, which is 3.4, and therefore the cost now is 170 plus 3.4, so we get £173 and 40 pence. So we get £173.40. Question number 19. One day a group of people had a driving test. 40 of this group were men and the rest were women. 3/5 of the men and 2/3 of the women passed the driving test. The number of men and women that passed the driving test was the same. We have to work out the number of women that took the driving test that day. Now, first of all, what we can do is find out the number of men who passed the driving test. And the reason we can do that is because we're given that 40 men took a driving test and 3/5 of them passed. So, first of all, the number of men who passed, well, this will be the same as the number of women who also passed. And this is of course equal to 3/5 times by 40. So 40 divided by 5, that's 8, timesing that by 3. What we have here is 24. So 24 men passed and 24 women passed. Now, we have to work out the number of women who took the driving test that day. So what we will do is we will let the total number of women equal x. So letting the total amount of women equal x, and that's what we're finding, what we know is 2/3 of the women passed the driving test. So 2/3 of x corresponds to 24. 24 of course passed the driving test. And we need to find out what x is. Well, timesing 24 by 3, you'd find 2x to equal 72, and therefore x is equal to 36. How does this help us? Well, it tells us that 36 women took their driving test. Question number 20. The diagram shows two intersecting straight lines, so that's what we see here. And what we have to do is find out the value of y. Well, what you can see is we've got vertically opposite angles. So therefore, this angle over here is equal to this angle over here. So we've got x plus 20 equaling 3x minus 50. And the reason for this, we have vertically opposite angles. So from this we can attempt to find out what x is. Well, if we take x from both sides, we have 20 equals 2x minus 50, and adding 50 to both sides, you will find 2x to equal 70, from which you can see x is equal to 35. And therefore what we can do is find out what this angle is equal to. We have 35 plus 20, which is 55. So this angle here is 55. And this angle here plus y will equal 180. So therefore, what we have is 55 degrees plus y equals 180, and the reason for this